All right, well, welcome. Today we're going to be talking about curb ramps and blended transitions. We are LRS Architecture. This will count for an hour of continuing education for your California licensed people, and we'll be sending out that certificate probably not till the beginning of next week, as well as the recording of today's episode to everyone who attended and registered for the event. So there will be that available. And then also wanted to let you know that we'll have an end for any questions that you have. So feel free to put those in the chat box. We'll get of those and we make sure we get anything answered at the end. We'll go ahead and get started. So for today's agenda, we're going to introduce ourselves as well as we'd love to hear from anyone who is new or returning to one of our CE webinars. Just go ahead and in the comments, let us know who you are and who you work with, and we would love to know kind of what areas you focus on as well. As we continue to put on these webinars, we would love to make sure that we are providing content that is helpful to the people that are attending most.
I'll start. I'm new to the webinar, and my name is Bill Weinberg. I'm an associate with Lionakis. We're located in Sacramento, and my primary focus is in the education field. We do higher ed and K-12 schools.
Welcome, Bill. We have everyone muted for now. If you want to hop on. Nope.
No, they're all on.
Yeah, so we're going to mute everyone, and then you can unmute yourself if you want to hop on and say hello and let us know who is joining us. I know we have a few other new faces, but after, and you can also just write it in the chat as well if you don't jump live. But we did want to let you know also that this will be recorded, so if you don't want your camera on for the recording, go ahead and turn that off. And then after introductions, we will be talking about transitions between pedestrian and vehicular traffic, giving an overview of what those code sections look like. We are going to be talking about the latest code updates that pertain just to curb ramps and blended transitions. Then we're going to give an overview of those as well as islands, really focusing on the transition, like we said, vehicular traffic. And we'll be talking about detectable warning. And then we will really be just giving highlights and overviews of all those and spending the bulk of today on examples, showing you real life pictures. As we know, the code is written really to an example that's one great scenario, and then get into real life, and it looks a lot different than the code describes. So we're going to be talking about how to design for real life situations and how that in the field we can create the best accessibility. A little bit about us in case you are new or you're watching this afterwards on a recording. We are LRS Architecture. I'm Erica. Lewis is going to be doing our presentation, and our focus is really on accessibility consulting, and we hope to help improve accessibility in the built environment. We work with architects, businesses, facility managers, and a lot of real estate professionals. Lewis, who will be doing our presentation, is a licensed California architect, and he's also a certified access specialist. He serves on the Certified Access Specialist Institute's board of directors. And he was also the first liaison on the Access Code Collaborative. So he helped create the language for the most recent code updates and is very familiar with the decisions that were made and the rationale behind that. So he'll go over a lot of those reasonings as he's talking about the code updates and then also talking about the curb ramps that we are featuring today. And if you didn't know, what we offer here as far as services go outside of our free educational resources, we also do CASP inspections and reports, and we have a full suite of options from due diligence reports 20% rule reports, and then full cast inspections and reports. We also do plan review and construction review, and then we do project consulting, where we get in really at the beginning conception of a project and help the accessibility move through a project seamlessly. And now I'm going to turn it over to Lewis, who is going to talk about transitions between pedestrian and vehicular traffic. Go ahead, Lewis. I'm going to mute myself first.
Good afternoon, everyone. Thanks for joining us. So there's lots of seminars we always think about doing. This has been a topic that's come up numerous times in the last few months. So I thought we'd kind of jump back, and we originally were going to just talk about curb ramps and blended transitions, but I kind of just expanded it to, that transition between the pedestrian and the vehicular way. As some of you may know, the term hazardous vehicular area is no longer part of the code. That was taken out as of July 21st, 2022. So if you still hear me referring to that, it's just old habits, but I'll try not to do it too much. Okay, so these are the sections of the codes that updated that specifically relate to this transition between the pedestrian and circular way. So there's new definitions for curb ramps, the scoping section. There's some minor changes to the wording for blended transitions. One of the major changes effective July 1st of this year was the addition of circulation paths in 11B 250. But I think this has spurred along some of this conversation, because one of the things that came about with this is really kind of an entire site planning change, with the requirement of having circulation paths raised 4 inches above the vehicular way. So then some of the technical sections, 406, which talks about parallel and perpendicular curb ramps, diagonal curb ramps, and then 705. There's quite a few changes to where detectable warnings should be. Can't see what? The participants. No one else is waiting. Okay. So what are the elements that really, this is not to pertain to pedestrian travel, but that this transition between the pedestrian way and the vehicular way. So there's blended transition, there's definitions for blended transitions and curb ramps. So that's one thing to look at. 11B 108, and I've got one example I'm going to show you, which is the maintenance of accessibility features. And this really pertains to any accessible item. Is there's this requirements that accessible features need to be maintained. And what I want to give you an example of is how a 4-foot wide path of travel is not maintained because of parking issues. And then the scoping sections that pertain is 206, which is accessible routes, 247 detectable warning, and 250 circulation paths. And then the technical requirements is in 450 and 705. So that's really kind of the code sections we're talking about today, and how they all kind of work together to create this transition. So the old definition of curb ramps, I can't see my full screen. Words. So the curb ramp is a sloping pedestrian way intended for pedestrian traffic, which provides access between a walk and a sidewalk, and surface located above or below. Can't read it. An adjacent curb face. So I hope everyone can see it on their screen. I can't see the last few words on mine. Okay, next. Sorry, some technical difficulties. So then the intervening code cycle, it kind of changed a little bit to say a sloping prepared surface intended for pedestrian traffic, which provide access between a walk and a sidewalk and a surface located above and below the an adjacent curb face. So just minor changes in the language. So perpendicular curb ramps. What are the code sections that apply to perpendicular curb ramps? So 406.2.1, running slopes, no more than 1 to 12, which is 8.33%. The flared sides can have to be less than 1 to 10%. They can't project into traffic lanes, parking space, and parking access aisles. They need to be 4 feet wide minimum. It needs to have a 4-inch top, 48-inch top landing. Grade breaks perpendicular. It must be perpendicular to the ramp runs. Cross slopes less than 1 to 48, which is 2.08%. The counter slope at the gutter it needs to be 1 to 20, which is 5% for at least 24 inches. And then in section 705, the detectable warning needs to be 36 inches in the direction of travel. For the full width, less 2 inches on each side. And it's supposed to be 6 to 8 inches from the vehicular area. So those are and I know I'm running them through real fast because what I really want to do is get into the samples, and we'll talk about how in a lot of cases, not all code requirements can actually be met. I didn't want this to be just going through the code and telling you what the code sections were in the code for curb ramps and blended transitions. So next slide. So parallel curb ramps. So per 406.3.1, this is kind of some new wording. The ramp needs to be in the direction of the sidewalk travel, and then the running slope can't be greater than 1 to 12. And I've got some examples to show how this code change makes it awkward for some existing conditions, which I would have normally considered a parallel curb ramp. The turning space is required to be 48 inch by 48 inches in slope in all directions, no more than 1 to 48. It needs to be 48 inches wide minimum. The top landing for parallel curb ramps there's no requirement for a top landing. There's an exception for that. The grade breaks here again need to be perpendicular to the ramp. Cross slopes 1 to 48. Counter slope 1 to 20 for 24 inches. 6 inches. Oh, that's a typo. Okay, 705. It's actually 36 inches from the vehicular way. So the depth of the detectable warning needs to be 36 inches, and the full width less 2 inches on each side. And then per 705 1.2.2.1, these are some added sections that talk about when you have one entrance into a parallel curb ramp or two, and then the entrances is actually from, typically an access aisle. So if there's only one entrance, you need to have, 36 inches of detectable warning and then a 36-inch walkway with no detectable warning. There's a couple exceptions that are in there. If it's technically infeasible, then you can reduce the detectable warning to 24 inches. The technically infeasible gets into where there might be a retaining wall or a building or a light standard that would be in the way, and it's technically infeasible to move something in order to get the width that's required. And then in exception 2, if the parallel curb ramp was built in compliance with an applicable code, then the 36-inch depth of the detectable warning is not required. Okay, yeah. So then for 2 entrances, you just have to have 36 inches on both sides and a 36-inch walkway in between, which is, if you look at these sections, you'll notice that the requirement at 406.3.2 only requires a 48-inch by 48-inch turning space. Although once you get into 705, it actually requires a 72-inch deep by 48-inch wide turning space, not the 48 by 48. So there was a question that talked about counter slope is the same as longitudinal slope. So the counter slope is actually what would be the running slope in the gutter or vehicular area. So this area that's out here, when you come down in this direction of travel, it cannot exceed 5%. Okay. This is my next slide. I'll get rid of this. Oh, there we go. Okay. This is my next slide. We did that one. I did perpendicular and parallel. Okay. Okay, so diagonal curb ramps. Now this is an example of a perpendicular curb ramp coming into a diagonal, but the same principles apply for parallel. So, for the curb ramp itself, the same rules apply as we talked about a minute ago. The additional requirements is that you need to have this landing that's in the marked crossing that comes out 48 inches in this direction. And then on each side here, there needs to be 24 inches of curb, all within the marked crossing. And this is a level curb. And here again, this is where that 5% slope would be. That's the counter slope for 24 inches. Okay. So blended transitions. By definition, it's a raised pedestrian street crossing, depressed corner, or similar connection between the pedestrian access route at the level of the side from one location in the structure to another during ordinary use. Mobile equipment includes, what's that? Oh, anyway, a blended transition. Let's go to the next slide. So the code sections for blended transitions are part of the same code sections as for curb ramps. So the slope can't exceed 1 to 20, so 5%. The minimum width is 48 inches. Blended transitions do require a top landing, 48 inches long. The slope can't exceed 1 to 48 in any direction. The grade break at top and bottom of blended transitions need to be perpendicular. Cross slope can't exceed 1 to 48. The counter slope at the gutter needs to be 5% for 24 inches. And there needs to, at that transition from the vehicular way to the blended transition requires 36 inches of detectable warning. And that too is the code requires that to be 6 inches minimum and 8 inches maximum from the demarcation between the curb and the vehicular way. So what I like to do when it comes to blended transitions and curb ramps is, since they're very similar, even when I see a curb ramp, if the slope is less than 5%, a lot of times I actually look at it as a blended transition instead of a curb ramp. So really, to me, a blended transition is anything less than 5%. And then a curb ramp is anywhere from 5.01% to 8.33%. Then, of course, obviously, if we get above 8.33%, it's a non-compliant curb ramp. So then islands are the other thing that connects pedestrian traffic with vehicular traffic. So in 406.6, it talks about it. You can either have a cut through median, or you can have a median that has curb ramps and an upper landing. The width of the landing itself needs to be 60 inches by 48 inches. In the diagram, it actually shows that the curb ramp is the 60 inches, but if you read the code, the curb ramp is still a 48-inch minimum, so it can come up 48 inches as long as the top landing is 60 inches wide. At least that's my interpretation of it. And then per 705.1.2.3, each end of the island needs to have 36 inches of detectable warning. The full width, less 2 inches on each side. And then the middle portion needs to be at least 24 inches wide. So once you get under 96 inches, you can reduce the detectable warning down to 2 feet wide, so 24 inches on each side, and then a 24-inch separation in the middle, so you're at 72 inches. Any islands that are less than 72 inches should not have detectable warning on either side. Okay. Huh? Oh. Okay, I can do that. Okay, I'm ready. So, so detectable warning. When I first started thinking about this, I was really thinking about how curb ramps and blended transitions all work together, and then only to realize that the detectable warning becomes still the biggest talking point, because that seems to be still the most problematic. So just a history of all the changes that have come about in detectable warning. So when I was on the Access Code Collaborative, DSA actually had a task force that it was put together to look at detectable warning and come up with recommendations and make code modifications to make it clearer where detectable warning should be. Now, there's a lot of code sections that were added as of July 1st, which defines where curb ramps, detectable warning needs to be at doors and ramps and other situations. I'm not going to talk about those today, so make sure you go and find those in the code sections. But anyway, DSA had a task force, and the task force came up with some recommendations through that process. That's where 11B 250 came into be. So the solution to the detectable warning in order to help somebody who's visually impaired was to raise circulation past 4 inches when they're, what's the right word again? Contiguous with vehicular way. So where those two meet, you're supposed to have a 4-inch vertical separation, and this is not only on a defined accessible route, but it's on any defined pedestrian route. So if you're walking through a parking lot or a parking garage, down a drive aisle, those are not defined pedestrian routes. So that doesn't apply, but anything that's a defined pedestrian route needs to be raised. Okay, so what? No, any circulation path. Okay, so now I'm gonna go through a bunch of samples and talk about some design solutions. So the main purpose and of detectable warning is to give somebody who's visually impaired notice that they're changing from the pedestrian path into a vehicular area. I mean, that is the purpose of it. As a sub result, that especially the reason that they're required to be yellow is so that somebody who's not totally blind can use it as a wayfinding method because of the contrast in color, and yellow is one of the easiest to see and the last color that you lose your vision on. Now, if you go through and you start reading all the background into detectable warning, it's actually not in, I mean, the code doesn't intend it to be a wayfinding solution, but that's what all the discussion revolves around when it comes to doing a lot of the code changes to the CBC. So here's a great example of a parallel curb ramp. This looks just like the image in the code. You have two sloping ramps coming down to a landing. I think this is actually a little older code, so we don't actually have the 36 inches behind. If you're looking at doing path of travel upgrades, this can start affecting some of the path of travel upgrades, because if this isn't completely compliant, you're going to need to look at moving this curb face back to allow a 36-inch space in between the detectable warning and that back of curb. So this is actually a sample of one of the expert witness cases I was involved in, where and you see these a lot, and you've been designing since the early 90s. This section was this illustration was actually in the code, where they showed, you know, the access aisle, and it terminated into a built-up curb ramp that was actually in the access aisle and in the parking space. A lot of us thought this was legal for a long time, but if you actually read the language of the code, none of this space, the parking space or the access aisle, was allowed to exceed 2% in any direction, and yet the code's drawing indicated the curb ramp. So now if any of you have any of these in your projects, make sure you get rid of them ASAP, because this is one of the big areas that lawsuits happen, mainly because somebody can drive up, see this out there, they figure it's a hazardous area, they don't even stop in, and they do this month after month, and all of a sudden it's a $30 or $40 or $50,000 lawsuit. So if you see these, get rid of them ASAP. So then here's some examples of detectable warning that that really give no visual aids to somebody who's visually impaired. So when I took this picture, the building entrance is behind me. And so this is apparently to provide a visual clue that something is going to change. This is actually a drive aisle, so the brick is a drive, you know, and the concrete is a driveway. But here again, it doesn't help anyone who's visually impaired, because they could walk right here. Oh, they can't see my screen, can they? Okay. I mean, they could get out of their car and walk right here and never know this detectable warning was even here. And by the way, that on the back side of me, there's no detectable warning to tell them when they actually got across the drive aisle. Okay, next. So this is actually a built-up curb ramp into the drive aisle. This is all a drive aisle. It's a turning area. And here again, I mean, the detectable warnings kind of put in the middle of space. It'd be easy to miss. It doesn't meet the 2 inches on either side of the curb ramp. This slopes shallow enough. I mean, it could actually be a curb ramp. It slopes more than the 1 to 10. So, you know, don't do things like this. So here's a curb ramp that comes down. The code, this is actually a compliant curb ramp because when it was constructed, detectable warning was actually required the full length of the curb ramp. And so one of the things that we always check when we're doing our accessibility reports is what's the applicable codes. Because if it meets the applicable codes, you don't actually have to change it. Now, what I would argue in this is that it actually doesn't meet the applicable code because the color of the detectable warning is really not a contrasting color. You can see it this, so the curb ramp is on one side of this marked crossing, and then it comes down and it turns a corner. And for some reason, there's detectable warning that's put into the driveway. I'm not sure exactly what purpose it's supposed to do. It's not a contrasting color, and it doesn't really tell anyone that they've reached a safe area. So like I said, if I were to write the report on this curb ramp, I'd actually recommend removing it and replacing it with a detectable warning that has a contrasting color. And in today's codes, I mean, it really actually says that all detectable warning has to be yellow. There are some exceptions. If you're replacing only a small percentage, then you can maintain the existing color, but the color has to be a contrasting color. So I ran across this a couple days ago. So here from this point, see that? There's a walkway that goes from that point all the way to the end of the walkway at this point. So I've kind of taken pictures in both directions. I'm quite confused as to why the detectable warning is placed where it's at, because if you are visually impaired and you're walking along, coming across this detectable warning is supposed to clue you in that now you're going to enter a vehicular area. But here it's just in the middle of the pedestrian walkway. I mean, this is supposed to be the pedestrian walkway. Cars can't get there because of the wheel stops. But yet they placed detectable warning in the middle. So this brings up some interesting concepts for how this would be solved in the new code, considering the 11B250, because 11B250, it limits the design options to only be able to separate the pedestrian area from the vehicular area with a 3-foot strip of detectable warning. There's no codes. It doesn't allow for the separation to be a curb. It doesn't allow for the separation to be a bollards. But if the two surfaces are contiguous, then the solution would be to be 36 inches of detectable warning. Of course, that means moving this entire walkway. Let's see, I think the walkway is 48 inches, so it'd have to be 36 of detectable warning and then 36 inches of walkway. So you'd need 2 more additional feet of walkway instead of putting down a row of bollards or other design solutions that might be available to us as designers. The only solution that's available is that detectable warning. Now, the other question is, and it's not defined in the code, is what does it mean to be contiguous? So if you separated the parking area from the walkway area with 6 inches of DG, is it no longer contiguous? You separate it with 2 feet of DG, is that no longer contiguous? So there's no true definition of what makes it contiguous and what makes it non-contiguous. Is that a word? Then as I continued along this path, I came across this detectable warning, which, as you can see, it's just in the middle of a walkway. It's just a walkway. And there was this little chunk of concrete right here, if you want to point it out, that has lips on both ends and slopes about 1 to 10. I don't know if the detectable warning is to warn somebody that they're about to trip, but it certainly doesn't belong here. You want to point to this area here. So that area right there is actually the sidewalk meeting the drive aisle, which is actually where the detectable warning should be located. So there's a great definite, place where that's the blended transition and requires detectable warning. Okay, next slide. How are we doing on time? Oh, 40. Okay. How many questions do we have? Okay. So here's another example of a blended transition. The parking space is actually on the left. You can see the access aisle, and you would definitely need detectable warning separating the pedestrian area from the vehicular area. So here's a perpendicular curb ramp. The top of it obviously doesn't meet code because it's not 48 inches. This should have been designed as a parallel curb ramp. Even the flares are built at like 25%, I think is what we measured them. The detectable warnings turned the wrong way. It should have been turned to be the full width of the curb ramp itself and only 36 inches deep, not, I think it's 48 inches deep and 24 inches wide or something. So, do I need to speak up a little bit, or am I doing okay? Okay. So I wanted to include this slide because the parallel curb ramp's fine. Actually, it's kind of a blended transition on one side, parallel curb ramp on the other. The solution that was designed, and this is designed long ago, was actually put a curb to separate the walkway that's down here. This walkway, because this is about a 20-foot wide walkway going back between a couple of buildings. And in order to keep somebody from walking into the drive aisle, they built a curb. Here again, under the new sections of the code, this curb is not an acceptable solution as a transition between pedestrian and vehicular. They need to be raised 4 inches. Okay, next. So here's an example of that parallel curb ramp I was talking about earlier, where it's definitely a curb ramp coming down to a landing. It's actually compliant even under today's codes. We have 36 inches behind it, 36 inches detectable warning, but it is not in line with the sidewalk. So this technically becomes a top landing, although under the new code section, it doesn't actually meet the requirements of a parallel curb ramp, which is that 406.3.1 section. Okay, next. So this is this was fairly new work done on a building we recently surveyed. And there's so many problems with this design that just shook my head the whole time I was there. The accessible parking spaces are actually across the drive aisle. So you come across the drive aisle and you meet this perpendicular curb ramp. Of course, the top landing, it sloped about 7%, and it sloped 7% all the way to the step going up to the door. As soon as you build this step, one step's considered a stair, so the step would actually require railings on both sides. And then this is actually a flare at sloping at 1 to 10, and then coming up to actually the pedestrian walkway that's accessible to the front door. It all slopes less than 5, so it's not a ramp. But this as the accessible route can't come down and hit a 1 to 10 slope and then down to the landing. This should have been a parallel curb ramp on both sides. Maybe even eliminate all this concrete so that everyone would actually have to walk up and around and come through this door. I think the landing was big enough you could actually come past the door and open it. But it could have been expanded a little bit more, I think. So, but that's some of the major problems with this curb ramp example. So then now we have a few slides in a row where we come down and meet an access aisle, and then what happens when you hit a curve. So this is a curb ramp. I think it's a curb ramp. It could just be a blended transition that may be less than 5%. And then you come down and the detectable warning is placed on the landing technically. And then it's cut so that it goes around the curve. So some of the issues that this brings up is, if you're visually impaired and you're coming down a slope and you hit a landing, that actually tells you to turn and change directions. And in this case, you hit the landing, but you're supposed to continue straight. Plus the requirement is to have 36 inches in the direction of travel, which this, because it's being cut on a curve, doesn't give you a full 36 inches in the direction of travel. Okay. If anyone has any questions, just put them in the chat, and we'll get to them right at the end. So this is when you look at the code section, all the elements can work together really nice as long as the vehicular way is perpendicular to the curb ramp, either a perpendicular or a parallel curb ramp. But once we introduce a curve into the equation, then something in the code is not going to be able to be complied with. So this is an example of what I would actually consider a perpendicular curb ramp. The ramp to landing demarcation, I like that, this right here. So it's actually perpendicular to the ramp. So that section's met. Now this is an older one, so it used to be allowed to have the lip transition between the curb ramp and the gutter. That's no longer allowed. That needs to be flush. This lip right here. But I wanted to include this example as more of talking points about how, how we can design this to actually meet all the code requirements. And in my opinion, it can't. I've seen this done a number of different ways, where the curb ramp itself is sloping from the top where it meets the sidewalk down to the gutter line. And in doing so, that actually makes it so that it's actually not compliant with section 406.5.6, which requires that that grade break be perpendicular to the ramp, because all of a sudden, you've kind of got this, the curb ramp is skewed slope. So I've seen it where it's designed like this, and the detectable warning is put on the face of the curb ramp and leaves the landing. This is how I actually design it. And then, but the landing then is because the code actually requires the detectable warning to be 6 to 8 inches behind that demarcation line between the curb ramp and between the curb and the gutter. So what you see a lot of times is the detectable warning follows that curve. Now, if it follows the curve, then it technically in the direction of travel, it's longer than 36 inches. But like on this, in order to have the grade break perpendicular to the curb ramp, now your detectable warning is going to be flat on the landing and then have to brake and go up the curb ramp, which would be kind of weird too. So in my opinion, that I have not ever seen a curb ramp on a curve that actually meets all the code section requirements. If any of you have, I would love to see them. So here's another example where the curb ramp's coming down, the detectable warnings put on a landing. And here that they maintain that one section of the code that requires it to be 6 to 8 inches back. It doesn't maintain the 36-inch requirement, but it maintains the 6 to 8 inch requirement. There's a delay from getting to your computer to my computer. This is an interesting one where they just put the detectable warning right in the middle of the curb ramp. Why, I don't know. Maybe because the bottom of that curb ramp is actually starting to curve a little bit and they didn't want to cut the detectable warning. So they just placed it right up in the middle. So the picture on the left-hand side, now obviously there's no detectable warning installed here. There should have been when it was built. But here again, the curb ramp comes down and literally there's a landing going between both of those marked crossings. So here's going to add a lot of confusion to somebody who's visually impaired. If you come down that curb ramp, you hit the detectable warning, and now you're on a landing, and it tells you that it's okay to turn and go to the left, to the right. Yeah, if you were walking down, you'd go turn to the right. But in this scenario, it's actually an accessible route to continue straight and then straight across. So no matter how the detectable warning gets installed in this situation, it's going to be very confusing to somebody who's visually impaired. And then the one on the right is similar to the ones we've seen before, where you come down and now you're on the landing and turning and coming across. That actually would work if it actually had detectable warning. So we have two samples of these long strips of parking spaces. So this is a pre-July 1st, 2022, where you come down. It's always been difficult to determine whether this is two parallel curb ramps and an accessible route, or is it a curb ramp with a really long landing. It's been topics of many discussions. So we're going to look at this one as one curb ramp, one parallel curb ramp with a landing. So the landing is designed so that it's a blended transition in between the walkway and the vehicular area. The only difference now is that this would be required to have 3 feet of concrete on the backside so that you can have a walking space free and independent of the detectable warning. Okay, next slide. So the same thing happens in this situation. So there's actually, so the curb ramp that you see on the bottom left is actually behind me on the picture that you see on the right. And then the upper one is the detectable warning you can see at the far end. So here's kind of an example of the same kind of thing where we have, it's either considered a curb ramp on either side of an accessible route, or it's a really long that landing. So in this case, this is actually the major accessible route from the public way. So in this design, as you come down the curb ramp, it's actually telling you you're actually entering a vehicular area. And as you travel across this accessible route, which is the kind of the wrong intentions of that detectable warning. So here it would either be put the detectable warning, along that entire strip, separating the vehicular area with the walkway. Truly the better solution from the get-go would have been to raise this entire walkway and have individual parallel curb ramps to each one of the accessible parking spaces, that's actually the solution they used on the back side of the building, and it would have been much more appropriate on this side as well. So what a curb ramp is not. A curb ramp does not connect a sidewalk to another sidewalk. A curb ramp only connects the vehicular way with the pedestrian way. So in this case, they actually had a series of 3 curb ramps going up because it was adjacent to the curb. They wanted to have it so it was a curb, and we redesigned it to actually make it so that we had a ramp portion coming up to a level sidewalk. So, and this is a great example. I see this all the time. And this gets into that 11B of maintaining the accessible route. The accessible routes required to be 48 inches wide. The parking space here is actually, I think, is actually 19 feet. So there's actually plenty of space for this truck to park. But it opted to back in. And as you can see, it completely blocks the accessible route. I mean, I think there's like 20 inches between that bumper and the edge of the concrete there. So then it gets to be whose responsibility is it to maintain the accessible route, and it really becomes the owner's responsibility to make sure that that this route is maintained. But I've seen this at Costco a lot, where their accessible route is right adjacent to the parking, and all the cars park over the sidewalk, and then it gets compounded because all the shopping carts are on the other side, and so now all of a sudden there's a 1 foot wide walkway and no accessible route. But it brings up an interesting concept of why, if you go and drive around, and actually when I did the survey on this, all the accessible parking spaces actually had wheel stops, because it was built under the 2016 code, and so they built it with wheel stops so that vehicles in the accessible spaces couldn't drive over and block the accessible route, but every other parking space in the entire development didn't have wheel stops, so everyone can drive over and block the accessible route. Okay. So here's an existing condition. This sidewalk's in horrible shape. As you can see, it has lips and slopes. Some of the cross slopes were about 4.5%, 5%. Some of the running slopes actually on this was about 13% in some cases. So the entire walkway was in need of being redone. But here again, we have this is actually the end of parking spaces. But it's because it's what's the word again? Because it's contiguous with the sidewalk. It now requires some kind of separation. So I actually designed a couple of different solutions to figure out which would be the better way to go, whether we separated it so it's not contiguous. If we added 3-foot detectable warning and then 3 foot of walkway, the little walkways to the doors needed to be adjusted a little bit. Another solution was actually to take the entire 5-foot wide walkway and put it adjacent to building and bring all the landscaping out so that that would be adjacent to the parking lot. So there's different solutions that we looked at to determine how best to solve the walkway situation here. So those are some of the ideas that I wanted to throw out when you're looking at how to solve this problem and get away from the contiguous solution when you cannot raise it 4 inches, because in this case, if you raise it 4 inches, then you can't get in the doors, obviously. And so that concludes it, but this is also a great slide. I was going through and it's like, so here we have an island, but the island only has detectable warning on one side. Imagine if you're visually impaired and you're coming down the accessible route, that accessible route goes out to the public way. You come down a curb ramp, which has no detectable warning, which it should. That detectable warning would let you know that you're entering a vehicular area. The vehicular area, then you come across and you would actually want to hit detectable warning on the other side of that landing, have a 24-inch strip in the middle, and then detectable warning again before you hit the drive aisle. Now that would be the old solution. The new solution is the parking and the walkway in between can't exist as it's currently designed. You either need to raise them or make them non-contiguous or separate them with detectable warning. One of the problems with that then, obviously, when you're coming down, let's say you put detectable warning along, along the face where it would indicate between the parking and the walkway on both sides. Okay, then when you're coming down this walkway and you come down a curb ramp, that would obviously require you to put detectable warning. But then the curb ramp, you're actually in a safe pedestrian zone. So that's one of the things to start looking at when you have curb ramps that are really not curb ramps. And so the better solution here would have been, it come down here instead of a curb ramp, slope it down at 5%. So it's just a walkway and then come to a flatter walkway. So all of these need to start being looked at a little bit differently, primarily because of that 11B250. So keep that in mind on when you're going through and. Oh. Okay.
So we are right at 1 o'clock.
Oh, wow.
We are going to go over. If you have to leave, we'll be sending this out. So if you can't take the questions, you can check them on the screen. But our first question is, could you please repeat the difference between blended transition and curb ramp?
Okay, so what I like to look at is that a blended transition is any connection that's less than 5%. So if it looks like a curb ramp, but it only slopes at 4.5%, I kind of look at it as a blended transition. Most of the same rules all apply. Sometimes I look at it as a curb ramp because it may not comply as a blended transition, but that's how I start to look at things. Is anything less than 5% is a blended transition. 5.01% to 8.33% is a curb ramp. Anything above 8.33% is non-compliant.
And then can you review the elevated requirements and do you have any compliance? I'm assuming that's talking about 11B250.
Yeah. So 11B250 is what talks about the 4-inch vertical separation requirement. We actually did our last seminar. We talked about 11B250. That's on our website. So we'll include the link to the website. And Erica, your mic's not working. Okay. Okay, next one.
Can you review the differences between the two different parallel ramps and why there's a difference between them?
So the question was, can we to review the two different parallel curb ramps? Do you want to go back to that slide? Yeah. Okay, so if you look under, I can't read the bottom, 705.1.2.2.2, that's the figure. So the difference really is, well, the requirement is to have 36 inches of detectable warning and 36 inches of walkway. So like in that that last slide I showed where we had parking on both sides, that would actually be an example of B, the two entrance and exit points. Because you have parking on both sides, so you're coming into the landing from both sides. And so the width requirement between those parking spaces is actually 6 inches of curb, 3 feet of detectable warning, 3 feet of walkway, 3 feet of detectable warning, and 6 inches of curb. So we're looking at at 10 feet from face of curb to face of curb requirement when you have parking on both sides.
So sorry, this is Hannah. What I was wondering about is that example on the very top of the page where you show a 48-inch wide walkway. So assuming that the depth of the detectable warning is 3 feet, what's that left over that leaves you with just 1 foot?
So this is so 406.3.2 requires a 4 foot wide walkway and a minimum 4 foot wide ramp. But because that figure did not change, I don't even think the code language changed in 406. And so there's actually a discrepancy in the code because 406.3.2 it will not meet the requirements of 705.
Right.
So even where it says 48-inch minimum, it really should read 72-inch minimum.
So this one is an error that you're saying, that top one image.
The figure is not, will not allow you to comply with 705. Correct.
Okay, thank you.
Okay, so the other problem with that figure too is it shows the detectable warning out at the face of curb where the asphalt meets the curb.
Right.
And there is a code requirement to have that 6 to 8 inches behind the curb. So there's a couple of problems with that. So one of the things, glad you brought this up because I don't know if I mentioned it. The diagrams that are shown in the code, this is that they're not legally binding. It's the language that is. So there's several sections in the code where the drawings, even though they're meant to clarify, are more confusing and sometimes often wrong. And so I don't know if you remember the slide that showed the code section from 1994, which showed that built up curb ramp, in the parking space and access aisle. But the same kind of thing there. I mean, and back then, what we did is we Xeroxed onto sticky back and just stuck the sticky back note onto the drawings. But that was, that ended up being built thousands and thousands of times, and it didn't actually meet the language of the code. So make sure you always refer to the language of the code, and then make sure that those code sections are compliant with other code sections, like in this case. One of the things I see a lot too is on ramps, where the code has a ramp, that shows, like 5 foot by 5 foot landings. And so then I'll go out and survey, or I'll review drawings, and the 5 foot by 5 foot landing is shown, but then they inset railings inside of that 5 foot by 5 foot, and all of a sudden you're, 4'2" by 4'2" inside clear, which doesn't actually meet the code but does that make sense? So you have to look at
Yeah,
multiple sections of the code sometimes in order to make sure you meet all code sections.
got it. Thank you.
Okay.
Thank you.
Oh, you're welcome.
Okay, so for the next question, it says for long passive travel with numerous accessible parking stalls, do we need to provide vertical separation in this condition with ramps and truncated domes with flush conditions at each access aisle?
So that's a good question, because when I was in the Access Code Collaborative, one of the main discussions was that they wanted to eliminate these long links of detectable warning. But when the final code got written, it doesn't really eliminate, because that was actually what the design concept was, is to have a whole series of parallel curb ramps coming down to a 4-foot landing, and then keep going back up and then back down and back up and back down. But I believe that can you find that the sample that has the detectable warning going that whole way? So I can't find it in the code where I can't consider a very long parallel curb ramp with a landing that stretches, across 14 curb ramps. 14 parking spaces with access aisles, and then separating it with 3 feet of detectable warning. The only requirement there is you have to have 3 feet of concrete behind it, so that you have a 3-foot walkway and 3 feet of detectable warning. Did that answer your question? We're trying to get to the slide. Like in this example, was
Yeah, correct.
so I think this is still an acceptable design solution, except for the fact that this is only a foot, there's only about 12 inches of concrete behind that detectable warning. It would be required to be 36.
Correct. So could you have a 4-foot ramp down to a 72-inch landing at the bottom? A 48-inch wide parallel ramp down, and then the bottom landing extends out to 72? Or would you need those both to be 72? It's kind of continuation of Hannah's question, I guess.
I would say it depends on where the 48 inches is. If the 48 inches is the leading edge of the detectable warning, so it's adjacent to the parking, I would say that that's probably problematic. But if there's, let's say that there's landscaping in between that, and the 48 inches comes down to have a 36-inch wide walkway, and then and it only encroaches into the detectable warning a foot. But let's see, is there a code requirement that would not allow that? And I would say no, not off the top of my head. My preference would be to locate the 48 inches as far away from the parking as possible. Does that make sense?
Yeah, that makes sense.
You're wanting to locate it at the curb line? Or just a general question?
I think that was more of a general question. Like in this example,
Okay.
could you have 4 feet down and then widen it to 72 once you hit the truncated domes?
There's like I said, there's nothing in the code that says anything different than that. Even though the diagrams show that the curb ramps are the same width as the ramp.
Yeah, as the ramp.
That's not necessarily the case. you know, literally like on that double loaded one where there's 36 and 36 and a 36-inch concrete space in the middle. I mean, if you had a 48-inch wide curb ramp going off that space in the middle, you don't have to have that concrete ramp the whole way. That makes sense.
Yeah, that makes sense.
Yeah.
How does the requirement for the elevated walks relate to this example? Like, isn't there a new requirement for elevated walks to separate the pedestrian and vehicular way? Does this comply with that?
Well, that's the question between, is this a very long parallel curb ramp, or is this a walk, you know, or does this need to be a raised walkway? And I don't find anything in the code that tells me that I can't have a very long parallel curb ramp.
This is pretty much what we're doing in parking garages, where we would have 36-inch wide detectable warnings parallel with the stall run of the stalls.
Yeah.
And then we would have 36-inch, because it's inside a garage, we would only have a 36-inch walkway behind in parallel with those, those detectables. Pretty much like what you had here, but just an extra couple of feet for concrete.
Right.
Yeah, that's what we're usually typically showing.
There's another, sorry, there's another image like when Hannah, like on the next page.
The next one.
The next slide on this, that most of the time we won't have the luxury of having 6 feet wide, right? So if it's a dedicated path only for ADA stalls, I guess that was a question too, is could this qualify to where you just have 2 parallel curb ramps at the end and then have everything flat in between?
So let's say, but let's say hypothetically, this lower image on the left, let's say there's a barrier there, and that this path is only serving accessible stalls, and they all have to go to the top of the page on the image to the right. This is where we would not have detectable warnings, right, Mahal?
Right, yeah. I guess that was my question, because I know Louis mentioned something earlier to where, okay, this is really not acceptable. You still need to have accessible, you still need to have detectable warnings in the whole strip, you know, maybe like 14 feet or something like that.
Right, so if this is a path shared by both accessible people and able-bodied people, general public, they're passing through, then you have to have that strip of detectables all along the run here. Sorry, Louis, we're just kind of taking over. Mahal and
Right, sorry, I'll unmute myself.
Wouldn't it always be for both able-bodied? I mean, anybody can use this. How do you
there's
distinguish?
there's an exception, I think exception 3, where if the path is exclusive to accessible stalls, you do not have to have detectable warnings. You have to have it where the raised path meets that accessible path only. I don't know if I stated that correctly. I'll be quiet
that's
now.
if you're only going to an accessible stall.
Right.
So, but when you're serving another accessible route, then it changes.
Right.
Right.
Okay. Did we answer the question? Okay, what's the next question? Oh, okay.
So the next question is when our EV seminar is scheduled for, and that is going to be on October 20th at noon. The registration isn't up, but we'll be sending out an email to everyone who's registered for this seminar or the last one with all the details about that as well.
Thank you.
Absolutely. The next question is on the parallel curb ramp diagrams. Are they shown incorrectly? And I think that's what we were just talking about, right? The discrepancies in the parallel curb ramp diagrams with 705.
Yeah, from between 406 and 705.
Yeah.
Yeah.
Okay, so the next question is, if an accessible walkway is required to be 48 inches clear, but there is a parallel curb ramp, new section 705 says that 36 clear is required behind the domes. Does the 36 inches take precedence, or does the 48 inches need to be maintained without encroachment from the domes?
Sorry, I'm going to end. This is Hannah again. I think the original question was for the current 2022 code. There apparently there's some kind of discrepancy. I'm not familiar with 2022.
Well, I think the question becomes, are you muted? Get an echo. So here, obviously, the code is addressing literally the bottom landing of the curb ramp. There's no mention in the code any place about the top landing or the ramp, other than because other than those being a minimum 48 inches wide. So there's really no code section that says that that the bottom landing that the ramp has to be as big as the bottom landing. The bottom landing and the top landing have to be as big as the ramp. So, and that's a minimum of 48 inches. So I don't think there's any code sections, I can't think of any off the top of my head, that require you to have a 6 foot wide ramp. It just requires you to have that width in the bottom landing. Was that the question? Huh? I can't see it. It's required to be 40. Yeah, I think I answered the question. Did we get an answer for you, Red?
I think they're off the call.
I'm here.
Okay.
I'm still listening.
Oh,
okay.
Kind of on the previous image that you had, where the accessible route would be going, say, past the accessible stalls and then out to the public way. Being as the code, and I'd have to look up the section, but it says that any exterior sidewalk has to be 48 inches clear. And so that the accessible route has to be 48, but then you have the domes and the stalls off the side of it. Do you really need a 7 foot walkway rather than only a 6 foot? Because otherwise the domes are technically 12 inches into your 48 inch clear walkway.
Yeah, but the domes can technically be in the walkway. That's why we see things like this where, that walkway is only 48 inches wide. And so that's a compliant walkway. It's 48 inches wide. I mean, that's the required clear width. So it really only takes effect on a landing in a parallel curb ramp. And that's the 36-inch requirement. Does that make sense? Actually, I mean, I would interpolate it as being, part of a blended transition too. If that's a blended transition,
Yeah,
I would
sort of. I mean, I think
36 inches of concrete.
I think it goes back to the 11B sections where the code talks about you can't reduce like a corridor width down to 36 any more than 24 inches in length, rather than maintaining the 44 or the 48. So the question's kind of coming back to that same thing of if your hallway or your corridor or your walkway needs to be 48 at all times, and now we're introducing a hazard because these domes are clearly hazards, then does that 48 need to extend past the domes?
I agree with you.
A short distance.
The fact that detectable warning, in my opinion, is we are required to put a architectural barrier on surfaces, but it can still be used as part of that 48-inch width.
Okay.
So it's just when the new code requirements came out, they did add the so 36 inches, which is really wide enough for a wheelchair to be able to go down and not have to interact with the bumps.
Right, and yeah, and we're well aware of that. We're just trying to figure out and kind of prepare ourselves for plan checkers that may not look at this the same way.
Okay, yeah. So, yeah, I think it's 36 inches. So unfortunately with accessibility, it's all up to interpretation, and unfortunately, you know, it gets to be where the authority having jurisdiction has the final say. So. Okay, any other questions? Great. I hope this was helpful for everybody. I appreciate everyone stopping in and attending, and look forward to talking to you guys again.
Thank you, Louis. Bye-bye.
Yeah, bye.
Thank you.
Yeah, if I can figure out how.